In this video, we are going to learn about what is SolidWorks. SolidWorks, it is an product of an desert system, and it is one of the mechanical design software. If you see any physical things around you, such as your computer or your mobile phone, there are high possibilities are there. Initially, it can be designed in SolidWorks or similar to SolidWorks. SolidWorks, it is an parametric based modeling. What is that? If you want to create any 3D model, initially we have to create two-dimensional sketch. Those things can be done in SolidWorks, and SolidWorks, it is an solid modeling. If you are designing or modeling in SolidWorks, means we can able to see that solid model, not the halo thing. If you are taking a cross section of that 3D model, means we can see the solid model, not the halo things. These are the things that is mainly focused on SolidWorks. SolidWorks, it is an well-known mechanical design software. We are going to learn about SolidWorks in more professional way. In this video, we are going to learn about what are the different versions of SolidWorks. For the part file, it should be in SLD PRT format. Assembly file format will be SLT ASM format. Drafting or drawing file format will be SLD DWG format. These are the different versions of SolidWorks. In this session, we are going to learn about how can we start a part in SolidWorks, what are the options or the interface or existing in SolidWorks, how can we adjust the document measuring units in SolidWorks, and how can we create the shortcuts by using the mouse, and how can we use the mouse for more effective modeling. In this video, we are going to learn about how can we start a new part in SolidWorks. These are the two options that are existing in SolidWorks when we launch the SolidWorks. The first option is for new document. If we select that option, means these are the three interfaces that are available in SolidWorks, and the first option is for to create a 3D model as a part, and the second option is for assembly. If you want to create an assembly means we can use this option, and the third option is for drawing or drafting. It is actually used to create the 2D drawings, and these are the additional options. If you want to, and this is like an advanced option, and the first option is for the templates in your organization. If they are creating any constant templates for the application means these will be appear on this platform. And the other option is like a tutorial option. If an organization is planning to provide any training on any of the module means this option will be appeared at this platform, and these are the appearance options which we can adjust as per your convenient. These are the options that are available in SolidWorks, and for creating a new part, initially we have to select a part module, and then we have to select OK, and this is the part interface that are available in SolidWorks. In this video, we are going to learn about what are the interfaces that are present in the SolidWorks, and the top portion of the screen is called quick access toolbar, and we can see some of the useful options are present over there, and we can see the options like new, open, close, save, save as, make drawing from part, make assembly from part, and these have the applications that are very useful. And the next option is like an editing option where you can see few other options, and the next option will be like an view option, and where you can see few other important option respective to that. And the fourth option will be like an insert option, and where you can see some of the useful features are present over there. And the above option is called quick access toolbar, and these are the options that are very useful for creating or accessing the document. And this portion is called comment manager, and these are the option is actually useful for creating a 3D model or to create the sketches for creating the model. And if you want to include any of the new option means we can just right click on that, and we can select any of the option as per our application, and we can use that. And the left side of the screen, design tree, and this option will actually consist of three important datum planes and these are the options which I have used to create this model, and there are a few other options at the top, uh, like a document manager, display manager, configuration manager, and these options are very useful. And this portion is called heads up toolbar, and where you can see some of the quick options, and the right side of this screen you can see like some of the options, and this options is called task plan, and these are the options that are actually very useful. And the above uh, portion is called SolidWorks search tab. If you didn't find any of the option means, and you can easily uh, find it by that option, and we have to just create a name over there, and then it will automatically show that on the comment manager, and we can easily find out that particular option by searching on that uh, tab. And the below portion is called like an uh, status bar, and this will actually display the document status, if the document is underdefined, or if the document is fully defined, and you can easily find out by that. Oh. And it will also help us to know about the sketches status as well, whether the sketch is in underdefined or sketch is in fully defined. It is actually very helpful for us to know the status of the document, and these are the three options that you can find at the bottom of the screen. And there is an option called model, 3D views, and motion steady. 3D views and motion steady are the two advanced options which we are not using in this course actually. And this center portion is called as graphic area, in which we can create a 3D model, or we can also create the assembly. And if you want to minimize the comment manager means, and we have an option called use large button. If we click on that means, and you can see like there is an actual minimize of the features. If you don't want to use that means, and you can again go for that option, and you can select that. In this video, we are going to learn about how can we adjust document measuring units. We have different forms of document measuring units, like inches, millimeter, centimeter, meters, kilograms, grams, bounds, and so on. And we have few other options that you can see at the bottom of the screen. Or you can also select the custom document measuring units from the available forms of document measuring units. We can adjust accordingly as per our application. In this video, we are going to learn about how can we utilize mouse for most effective 3D modeling, and how can we create a shortcut in mouse, and we have an option in quick access toolbar, and we have an option called customize, and we have an option called mouse, and you can find a few other shortcuts that are present default in the mouse. And if you want to modify the shortcuts in the mouse, means we can select that option, and we can replace that option as per your convenient way. And you can also create a new shortcut by using that. If we want to assign any new shortcut, means we can also create a new shortcut. Now you can see how the shortcuts are useful for creating a 3D model. And here I am using sketch by shortcuts, and here we can create a sketch by using the shortcut. In this session, we are going to learn about how can we select the datum plane to sketch on, how can we link sketch to datum plane, how to convert the design thoughts in the form of sketch, how can we add the distance to define the sketch, creation of angled line, adding the relation to the sketch, adding the relation automatically, knowing and deleting the active relation, additional options like construction line and center line, and few other sketching comments like mirror, offset and pattern. In more practical and professional way, we are going to learn each and every concept detail on this session. In this video, we are going to learn about how can we select a plane for sketch. If you want to draw a sketch physically, means we need a sheet. Similarly, if you want to create a sketch in SolidWorks means we need a plane. There are two methods to select a plane. We can select the plane from the design tree. As you can see, there are three different datum planes are present in the design tree. You can select any one of the datum plane, right click on that, and you can start sketch from that. And the other method is we can go to the comment manager in sketch toolbar and you can find an option called sketch. After selecting the sketch option, you can select the datum plane and then we can start the sketch on that datum plane. These are the two methods to create a sketch on the datum plane. In this video, we are going to learn about how can we interlink the sketch with the plane. As you see on the screen, the shown sketch is actually created in top plane. If you want to interlink the same sketch to the front plane means, and we can have an option, right click on that sketch and we have an option called edit sketch plane, and there you can see that in which particular plane the sketch was created. After that you can delete that plane and you can interlink the other plane by the design tree. And now you can see like that a sketch is now interlinked to front plane, and you can also interlink the sketch to any other planes as per your application or as per your need. And here I am interlinking the sketch again to right plane, as you can see that on the screen. In this video, we are going to learn about how can we create the sketch profile like triangle, rectangle and polygon by using the sketch profile. And we have a sketching option that you can see that on the sketch toolbar, and we have an option called line, and we have to start the sketch from the origin. And you can see that, and there are like few symbol as we move the cursor accordingly, and we can see the symbol like horizontal, vertical and angular symbol as we are moving the cursor point accordingly. And here I have created the triangle by using a line command. If you want to end the line means we have to double click on that. And you can see another two line option that you can see that, and there are like center line and midline. Centerline is actually used for the reference purpose. Midline is actually used to create the line on both the sides equally and simultaneously. And we also have an option called rectangle, and there are like a few other options in that. And the first option we can use to create the corner rectangle, and the second option is to create the rectangle from the center, and we have to select two points for that. And the first point is for defining the center, and the next point is to define the end of the rectangle. And the other option which you can see that, and that is a 3-point corner rectangle, and we have to define 3-point. And the other options like 3-point center rectangle, and we have to define 3 points for that rectangle. Initially we have to define the center of that rectangle. After that we have to define the second point in that rectangle to define the corner of that, and the another point is to define the end of that rectangle. And the fifth option is for creating the inclined rectangle, and here we have to define the rectangle by 3 points. Like first point is to define the start of that rectangle, and the second point is to define the another end of that rectangle, and the third point is that for to define the inclined angle of that rectangle. And you can also find an polygon icon in the sketcher comments, and if we select that icon means, and we can see that, and we can define the polygon by 2 points, and the first point will be like the center of the polygon, and the next point is to define the end of the polygon, and we can use that as per our convenient way. In this video we are going to learn about how can we create circular profile like circle, arc and ellipse by using sketcher options. And here you can see like I have creating the circle by selecting the circle icon, and here you can see there are 2 other subdivisions are available, and the first option is for create a circle by center of this circle, and the second option is for creating a circle from a perimeter of that. And this option is to create the arc, and there are 3 different options are available to create the arc. And the first option is for create a arc by selecting the center of that, and we have to define a point by selecting two other end of the arc. And the second option is for creating a tangential arc, and here we can create the tangential arc by the end of the profile, which you can see that on the screen. And the third option is for creating the arc by perimeter. Here I am defining the arc by two end of the arc, and then I am defining the center of the arc. And here you can see the another option like slot, and there are four subdivisions are available in that arc. And the first option is to create an arc by defining the points. Initially we have to create a slot by defining the center line of that arc. And the second option is to create a slot by defining center of that slot, and then we have to define the end of that slot. After that we have to extend that slot. And the third option is for creating a slot by an semicircle way. In this option we have to create a slot by defining three other points, which you can observe that on the screen, which I am actually creating the slot by defining three other points. After that we have an option called spline. Here we have to define the start point of that of the spline. After that we can select point in the spline as per our application. And in this option we can create ellipse, and you can find there are 3 to 4 subdivisions in ellipse. And here I am actually creating the ellipse by center of the ellipse. And here we have to define the ellipse by selecting the center of that. After that we have to select the point of the ellipse. And the other option is like we have to select the center point. After that we have to select first and last point of that ellipse. That ellipse is called partial ellipse. And here we can create a parabola, and we have to define 3 different points. Initially we have to define a center of that. After that we have to define starting and ending of the parabola. In a conic option, which you can see, we have to define the conic by 2 ends of that. And after that we have to define the third end point, which you can see that on the screen. And the other option in Sketcher command is like fillet. The fillet is actually used to break the sharp edges on the sketch edge, which you can see that on the screen. For that I have created the rectangle, and we can break the sharp edges by using the fillet option. In this video, we are going to learn about how can we define the sketch by using distance. This sketch is still underdefined, and you can see that a sketch is in blue color. A blue color indicates that a sketch is in underdefined, which you can observe that at the bottom of the screen. If you want to add the distance to the dimension, means we have an option called smart dimension, which is available in sketch toolbar. Initially we have to select that option. After that we have to start giving the dimension by selecting the sketch. As you can observe that on the screen, a sketch is now converted into black color from blue color. A fully defined sketch will be in black color, and you can also observe that at the bottom of the screen a sketch is now fully defined and the sketch is fully converted into black color. And we have to give the dimension from the origin. In this video, we are going to learn about how can we create angled line. For that, initially we have to select any one of the datum plane. After that, we have to select line command. As you can see, there are few orientation options on the left side of the screen. We have to select angle option, and there are a few options which you can observe that at the bottom of the left side screen. And we have to provide the specific parameters of that line, and here we have to provide the angle and dimension of that line. After providing the specific value, we have to start the dimension from the origin. After that, we have to provide the end point of that line, whether we can provide it at the bottom side or at the top side. This will be the one manual method. The other method we can create the angle line will be like, initially we have to select the plane. After that, we have to select the line icon and we have to draw the line with certain angle. After that, we have to provide the specific dimension by using smart dimension. Here I am providing the angle as well as the parameter of that line command. In this video, we are going to learn about how can we define a line by using a relation. These are the two individual line. Initially we have to select the line. As you can see, few options are available on the left side of the screen. Initially we have to select the line. After that we can add the relation to that line by selecting that particular relation. As you can see, now I am selecting that inclined line. After that I am selecting a vertical relation. Now you can see inclined line is now converted into vertical line. Here I am creating another line. This line is an inclined line. If we want to add the relation in between two lines, means we have to select two lines by pressing Control key. As you can see, there are few other relation options that are available at the left side of the screen, and we can add any of those relations as per our application. Now I am adding like perpendicular relation for those two lines. As you can see, the inclined line is now converted into vertical line, and those two lines are perpendicular to each other. After that, again I am selecting two lines by pressing Control key, and now I am adding the relation like equal, and now you can see length of both the lines is equal now. Here I am creating one more line. Here I am selecting two lines by clicking on Control key. Those two lines is now parallel. If you want to add any other relations, means we can define the line by using a Control key, and now you can see the both the lines are aligned to each other. As I have used collinear option, we can also fix that particular line. As you can see, the horizontal line is fixed. In this video, we are going to learn about how can we define a circle by using a relation. Here I have created two circles. If we want to define the circle, means initially we have to select circle After that, you can see the options at the left side of the screen. Here I am selecting equal option. As you can see, both the circles are equal in circumference. Here I am defining the circle as 50 mm, and here both the circles are fully defined. Here I am adding the relation between these two circles. Initially we have to press the control key. After that we have to select those two circles. As you can see the options at the left side of the screen. Here I am selecting a concentric. Here both the circle are concentric now. Same thing I am repeating on the other side as well. If we want to add the relation for these two circles, means we have to press control key. After that we have to select both the circles, and we can select the relation like equal. If we defined any one of the circle, means the other circle is automatically it will defined. As you can see, there is a change in color from blue to black, and here you can see that a sketch is fully defined now. Here I am creating ellipse now. Here we are defining the ellipse by adding the relation to that. In this video, we are going to learn about how can we add a dimension or relation to the sketch automatically. The sketch is underdefined now. As you can see, the sketch is in blue color. If you want to add the dimension or the relation automatically, means we have an option in the sketch toolbar, delete or display relation. As you can see, there is a drop down. If we click on that drop down, and we have an option called fully defined sketch. If we select that option, we can find an option at the left side of the screen, calculate. If we select that option, means you can see the sketch is fully defined with the necessary dimension as well as with necessary relation. Sketch is converted into black color. This will be the easy way to define the sketch. We can also alter the sketch by selecting the dimension of that. In this video, we are going to learn about how can we know or delete the existing relation in the sketch. The sketch is fully defined now. As you can see that sketch is in black color. If you want to delete or to know the relation in the sketch, means initially we have to select the sketch, and we have an option in the sketch toolbar, display or delete relation. As you can see, all the existing relation at the left side of the screen. If you want, you can delete the individual relation in that, or if you want to delete the entire relation, means we have an option called delete all. We can delete all the relation in one shot as well. In this video, we are going to learn about some of the additional lines like construction line. In this sketch, as you can see, there are both normal line as well as construction line. If we want to convert normal line into construction line, means initially we have to select normal line. As you can see the options at the left side of the screen, and we have to select that option as for construction. As you can see now, the normal line is now converted into construction line. Or if we want to convert the construction line to normal line, means again we have to repeat the same steps again. As you can see that on the screen, and now the sketch is converted from construction line to normal line. In this video, we are going to learn about few other sketch comments like offset, mirror and pattern. If we want to offset any sketch, means initially we need a base sketch. We can find an option in the sketch toolbar. We can find an option like offset entities. After selecting that option, we have to select the sketch. At the left side of the screen, we have to enter the specific value at which the sketch has to be offset. And here I am entering the value like 10 mm. And we have an option called reverse. And we can select that option whether the sketch has to be offsetted inside the sketch, or we have to offset the sketch outside the sketch. We have an option called bidirectional. Bidirectional is generally used to create the sketch on both the sides. And we have a few other options like construction geometry. And we have a sketch will be converted into construction line. As you can see on the screen, the sketch will initially converted into construction line if we select that option. And we have few other options like mirror entities. If we want to mirror the sketch, means initially we have to create an axis at which the sketch has to be mirrored. After selecting the mirror entities, we have to specify the sketch as well as the axis at which the sketch has to get mirrored. If you want to create the series of same profile, means we have an option called linear pattern. This is actually used to create the same profile of sketch at the different places. Initially we have to select the sketch. After that we have to add the specific value as an After defining the specific value, we have to specify the number of profile it has to form a pattern. After defining all those, we have an option called angle. If we want to pattern the sketch at specific angle, means we can enter it manually. As you can see on the screen, here the sketch is created at the specific angle. In this session, we are going to learn about conversion of a 2D sketch into 3D model. What are the features and its uses? Basic features like extruded base, a cut exclude, conversion of sharp corners into circular corners, deleting and editing the existing features, and how can we convert sharp edge into flat edge by using SolidWorks options. In this video, we are going to learn about what are the features and uses of it. Features are the invisible shape when combined, made as a part. We can also add some type of features in assemblies as well. Features includes multi-bodies parts. We can also include separate features like boss exclude, cut exclude, or some other features command. Generally, if we want to convert 2D sketch into 3D model, means generally we use features. In this video, we are going to learn about how can we convert 2D sketch into 3D model. How can we remove material? How can we convert sharp corners into round corners? This is the 3D model which contains all the three features in it: boss exclude, cut exclude, and fillet options as well. If we want to convert 2D sketch into 3D model, means basically we need sketch. For creating the sketch, we need a plane. For that, here I am selecting the plane. After that, I am creating this sketch on that. After that, we are defining the sketch. If you want to convert 2D sketch into 3D model means we have to use features toolbar. In that we have to select exclude base for add the materials to the 2D sketch. In 3D model, all the faces are considered as plane, and we can create the sketch on any of the faces. Here we are selecting a top face to create the sketch on that. As you can see, here we have created the sketch on the 3D model. After that, to remove the material, we have an option called cut exclude. For that, it will be present in features toolbar. After that, we have to specify the specific value at which depth we have to remove the material, and we can also find few other options in that, like through all. This option is generally used to remove the material until the end of that 3D model. As you can see, some other options like up to the surface. For that option, we have to specify the surface for that until which material will be removed. Here we are converting sharp edges into round edges. For that, we have an option called fillet. Here we are selecting all the four corners of the rectangular bar. As you can see now, sharp edges is now converted into round edges. In this video, we are going to learn about how can we delete or edit features. There are 3 features to create this 3D model. If you want to delete the feature means, as you can see the features on the design tree, we have to right click on that features, and you can find an option called edit features. After selecting that option, we can increase the material in that features as well. Also, we can add the value as a direction too as well. If you want to edit the features on the cut exclude means, we have to follow the same procedure as before. If you want to delete the existing features means, we have to right click on that feature on the design tree, and we can find an option called delete. We can select that option. If you want to create any additional feature means, we have to drag the design tree until that, and then we can create the sketch on the plane or on the face, and you can add the feature on that will be included in the 3D model. In this video, we are going to learn how can we convert sharp corners into flat corners. For that, we have an option called chamfer that can be found in features toolbar. You can find one drop down in fillet option. As you can see, chamfer option in that. After select that option, we have to select the sharp edges in the 3D model. As you can see, there are few other sub options are there. Initially, we are going to learn distance chamfer. In that, we have to add specific distance at which it has to be takes place. As you can see that on the screen. After that, we have an option called angle distance chamfer, where we have to specify the angle. After that, we have to specify the distance. Again, we have one more option called vertex chamfer. Vertex chamfer is generally used to remove the sharp edge of the 3D model. We have to give the specific value for that. As per the specific value, the material will be removed from the 3D model. In this session, we are going to learn about some of the advanced feature commands like revolve base, revolve cut, swept base and swept cut. How can we create reference geometry in part module? How can we create loft base and loft cut features? In this video, we are going to learn about one of the complex features like revolve base and revolve cut. For that, initially we have to create sketch on the plane. Here I am creating the center line. After creating the sketch, we have an option called exit sketch. After that, we can select revolve base in the features toolbar. Here we have to select the axis of revolution. We have to specify that in the sketch. As you can adjust the angle of revolution. Here we can adjust the angle of revolution as per our convenient, and we can also add direction 2 as well, and we can also add the angle of revolution in that angle as well. After adding the specific value, we have to select OK. As you can see, 3D model is created. Here we are creating the another sketch for the revolve cut. For that, initially we have to select the plane. After creating the sketch, we have an option called revolve cut. After selecting that option as well, we have to specify the axis of revolution. As you can see, material is removed inside the 3D model. If you want to see that, means we can use session view. In this video, we are going to learn about swept base and swept cut, and these features are very useful in pipeline industry. If you want to perform this feature, means we have to create two sketches which is in perpendicular to each other. One sketch is considered as profile and the another sketch will be considered as path for the profile. Initially, we have to start creating the profile. After creating the profile successfully, we have to exit the sketch. For creating the path, it should be exactly perpendicular to the profile. For that, we have to select another plane. Here we have created the path which is exactly perpendicular to the profile. After creating the path, we can perform an operation called sweep base. It can be found in features toolbar. In that, we have to select one sketch as a profile and the another sketch as a path. After selecting the sketch, we can see the 3D model as created. For the sweep cut, we have to create two separate sketches which are perpendicular to each other. Here we are creating the profile and then we are creating the path which is perpendicular to the profile. From the center of the profile, as you can see, two separate sketch on the design tree. Now we can select sweep cut, which is in features toolbar. Here we have to select circular sketch as a profile and the line sketch as a path. Now you can observe that the material has removed. In this video, we are going to learn about how can we create reference geometry. For that, we have to launch part module. As you can see, there are three datum plane in the design tree. If we want to create reference geometry, means we have an option which is present in features toolbar. After selecting the plane as a reference geometry, we have to define the reference for that creation of plane. Here we are using a datum plane as a reference, and we can also add the distance between them, and we can also increase the number of reference plane by increasing the numerical value. We can also create perpendicular reference plane as well. For that, we can use mid plane option. We can also create angular reference plane also. For that, we can use angular option. In this video, we are going to learn about how can we create loft base and loft cut. Loft base is generally joining the three different sketches on the three parallel planes. This feature is very helpful for creating a complex shape model. Initially, we have to create the parallel reference plane. After that, we have to create the sketch on that plane individually. As you can see that I have created the different profile on the different plane which are parallel to each other. Here we are connecting all the sketches by using a loft base, which is present in features toolbar. After selecting a loft base, we have to select the sketches in the profile session. As you can see that 3D profile of loft base is created by joining three different profile. Loft cut is generally a material removal process. For that, we have to create the different sketches on the different parallel lines. As you can see that on the screen, I have created the different sketches on different parallel planes. These different sketches can join together by loft cut. Now you can see that material is removed on the 3D profile. Like this, we can create a complex shape module. In this session, we are going to learn about how can we assign the material for the 3D model, and how can we view the properties of the assigned material by using SolidWorks options. In this video, we are going to learn about how can we assign the material for the 3D model. For assigning the material, we have an option called materials in the design tree. We have to right click on that, and we have an option called edit material. We have to select any of the material which are available in the SolidWorks. There are categories of materials under subdivisions. We can assign any of the material as per the application. After selecting the appropriate material for that 3D model, we can apply that material to that 3D model. As you can see that on the screen, the applied material is assigned to that part. If you want to edit the assigned material, means we have to again right click on that material, and we have an option called edit material, and again we can see all the available options material as well. And now you can select any of the material as per the application, and we can also see some of the mechanical properties as well in that. In property toolbar, and we can also see appearance of that particular material in a appearance toolbar. In this video, we are going to learn about how can we find the properties of an assigned material. The shown 3D model is assigned with SS304 material. If you want to know the properties of that assigned material, means we can find that properties in an evaluate toolbar. In that we have an option called mouse properties. If we select that mouse property means we can find properties of an assigned material like density, mass, volume, surface area, center of mass, and these are calculated in cubic mm. If you want to change the unit of that means we can change document measuring units. In this session we are going to learn about how can we open assembly file, mates and its types, adding the parts in an assembly module, and some of the standard mates like concentric, parallel and perpendicular mates, tangent, concentric mate, finding an existing mates, deleting or modifying the mates. How can we create a reference geometry in assembly module? And some other types of mates like distance, angle mates and log mates and its uses in industry aspects. In this video we are going to learn about how can we launch the assembly module for the first time. When we launch the SolidWorks software, we have two options at the top of the screen as a new document and existing document. Initially we have to select new document. If we select that option means we will get three options: part, assembly and drawing option, and we have to select assembly module. After selecting assembly module, we can see all the assembly interference like comment manager at the top of the screen. Graphic area at the center of the screen, and three different datum plane of an assembly. We can find it in an design tree. In this video we are going to learn about mates and its types. Mates are used to add positional relation between one another. We can find mates in assembly toolbar. If we click on the mates, we can find different types of mates like standard mates, advanced mates, and mechanical mates. In this course, we are going to learn about standard mates individually. In advanced mates, we can quickly place an component and create a shortcut which helps you to perform better assembly. For the mechanical mates, used to assemble the mechanical components like gear, rack and pinion, screw, and so on. In this video, we are going to learn about how can we add parts in an assembly module. In assembly toolbar, we have an option called insert component, through which we can insert the parts in an assembly module. If we click on that insert component, we can find an option. We can select the parts from the recently opened document, or we can browse the parts from the system. After selecting the part from the system, we have to place the part in the graphic area. The placed part is now fully fixed. This will be not the current procedure for assembly. We have to initially float the part by right click on that part in the design tree, and we can find an option called float. After that, we have to mate the part with respect to assembly datum plane. Here I am mating the front plane of the part to the front plane of an assembly module, and here the part is arrested in one direction. Still we have to arrest the part in two more direction. For that, we have to again mate the part with an assembly module. Like here I am mating the part again with assembly module. Like top plane of the part is made with the top plane of an assembly. Like this, we have to make the part in an assembly by imagining the orthographic view of an assembly. We have to make the part with respect to orthographic view. In this video, we are going to learn about how can we assemble the parts by using mates. Initially, we have made the base part with respect to assembly module. After that, we are inserting the part through insert a component. After inserting the part to the assembly module, now the part is free to move in all the direction. The part is under define, which you can see at the bottom of the screen. If we want to mate the parts, means we have an option called mates in an assembly toolbar. We are using standard mates. Here we are using coincident mate, parallel mate, and perpendicular mate are used to mate the flat face of the part. Here you can see we are using a parallel mate in order to fix the part with respect to the base part. We can also use perpendicular mates to add the positional relation with the base part. Here we have to use coincident mate in order to add the positional relation with the base part. Coincident mate are generally used to mate the flat faces. In this video, we are going to learn about another two important standard mates like concentric and tangent mate. Concentric mates are generally used to mate two circular profile. Initially, here we are using coincident mate to mate the flat part. After that, we are using concentric mate to mate the circular profile, and we have an additional option called lock rotation that will be like optional. If we want to lock the rotation of the circular profile with respect to the base profile, means we can use that option. Here we are not using that option. As you can see, still the part is underdefined. If you want to make the part like a fully defined, means we have to use another mates to lock the rotation. Here we are using another parallel plane mate to lock the rotation. Here we are going to see the tangent mate. Tangent mate are generally used to mate between the flat face and circular face. Here we are using the tangent mate. In this we can see that the circular part is sliding along the flat face. Still the part is not fully defined. Here we have used only one mate. We have to use at least 3 mate to define the part. In this video we are going to learn about how can we find the existing mates and how can we delete and modify the existing mates. If you want to find out the existing mates are present in the part, means we have to click on the drop down of the part in an design tree, and we can find an option called mates in assembly. The entire assembly is called assembly 2. If we are naming the assembly as some other name, means it will implement it in the design tree. If we click on that drop down, means we can see what are the existing mates are present to use to mate the part with respect to the base part. If we want to delete the existing mate, means we have to right click on that mate and we find an option called delete, and we can delete that unwanted mates. If we want to modify the existing mate, means we have to click on that mate and we find an option called edit feature. If we select that feature, means and we can see what are the possible modification are available. If we can change into any possible modification, and we can change the mates by selecting the another mate which is in the standard mates column, and you can see that the another two options are invisible, like tangent mate and concentric mate. Those two options are generally used to mate the circular profile. As we know, we can't able to use those mates in flat profiles, and here we can see only the possible mates. As you can see that here we have changed the mate from parallel mate to coincident mate, and here the part is fully defined, which you can see at the bottom of the screen. In this video we are going to learn about another two important mates like angle mate and distance mate. We have to assemble the triangle part in that triangle cutout which is in base part. For that, initially we are using coincident mate to mate the flat face. After that, we are using angular mate at a specific angle. Angular mate and distance mate, we cannot use it together. For that, we have to delete any one of the mate. Here I am deleting angle mate. Distance mate is generally used to add the positional relation at a particular distance. As you can see now, we are using a distance mate at a specific distance, and here we have to again use coincident mate to mate the part in their place. In this video, we are going to learn about lock mate, lock mate are generally used at worst cases if we can't able to add the positional relation with other mates, means we can go for lock mate as an end option. In this mate, we have to place the part at a specific place, and then we can use lock mate to fix the part at that position with respect to another part. Here we can able to define the part by single mate, lock mate. Other mates are not required after using lock mates. In this video, we are going to learn about how can we create a reference geometry in an assembly module. We can find an option in an assembly toolbar as reference geometry. If we select that option, means we have few other sub options are present in that. If we select plane, means we have to specify the reference to create that plane. We have to specify the specific value for creating the distance plane. If we want to create a reference plane at the center of the assembly, means we have to select reference as both the sides of assembly, and we can also add the reference axis. For that we have to select reference axis from reference geometry. For the reference axis we have to select any edge in that assembly. We can also create a reference coordinate system. For that we have to select at the bottom of the assembly. We have to add the reference for that, and we have to select the reference edges like X, Y and Z axis. As you can see, we have created a reference coordinate system at the bottom of an assembly. In this session, we are going to learn about 2D drawing. 2D drawing is very important if we want to submit our design to our client, means we have to submit it in the form of 2D drawing. If we want to convert our design to manufacturing, means we have to submit it in the form of 2D drawing. In this session we are going to learn about opening the drawing file, adjusting the document, measuring units, creation of standard orthographic view from the part, change the scale of the drawing, communicate using drawing. What are the information has to be provided to the manufacturing department, and conversion of drawing in the form of PDF or in image format. In this video, we are going to learn about opening the drawing file for the first time. After launching the SolidWorks, we have two options as you see at the top of the screen: new document. After selecting that document, and we will get three interface parts: assembly and drawing. Here we have to select drawing. After that we have to select standard sheet format, and we can also select sheet format as per organization standard by browsing in our system. And here you can see drawing interface. The top portion is called comment manager, and the left side of the screen you can see design tree, and these are the drawing interface. In this video we are going to learn about how can we adjust document measuring units, and there are different terms of document measuring units like inches, millimeter, centimeter, meter, pounds, and so on. If you want to adjust the document measurement units, means as per our organization, means we can see an option at the bottom of the screen, and we can find few more option. In that we can choose the existing one, or we can select custom option to select your own document measuring units as per your company standards. In this video we are going to learn how can we create orthographic views in the drawing sheet. For that we have to select standard three views from view layout toolbar. In that we can select the recently opened part, or we can browse in our system. After selecting the part, we can see standard three orthographic view on the sheet, and these views are front view, side view, and top view. If you want to create any individual view, means we have an option called model view in the view layout toolbar, we have to select that option and browse the part in the system. After that, we can select the required view from the left hand side. On the screen you can see the options like orientation. If you want to change the display style of the part, means we have an option at the left side of the screen. As you can see the display style option, we can select any one of the option as per your application. In this video, we are going to learn about how can we adjust the scale of the drawing. For that, we have an option called sheet format at the left side of the screen. If we right click on that and we find an option called properties, if we select that option, we can see the scale of the sheet. We can change the value of that scale of the sheet. Now you can see scale of the drawing is adjusted as per the scale of the sheet. If you want to increase the scale of the drawing individually, means we have to click on that drawing and you can see few options on the left side of the screen. We have an option called scale. In that, we can select any of the existing value, or you can enter the user defined value in that. Now you can see that drawing is adjusted as per the scale which you have given. We can also change the display style. As you can see, few options under the display style. We can change as per the convenient. In this video, we are going to learn about how can we communicate through the drawing. If you want to communicate through the drawing, means we have to give proper dimension to the drawing. It will be helpful for manufacturing department. If you want to give dimension to the drawing, means we have an option called smart dimension, which will be in annotation toolbar. Initially we have to select that option. After that, we can add the dimension to the drawing. Here I am adding the horizontal and vertical dimension to the drawing. And if we want to add the center mark of the hole means we have an option called center mark in the annotation toolbar. After selecting that option, we have to select the circular hole. Now you can see that center mark in the hole. We have to add all the necessary dimension to the part. It will be easy for the manufacturing department to manufacture the parts. As you can see here, we have given all the necessary dimension in all the direction. For example, we have to cover vertical, horizontal and height of that particular part as well. We have to give all the required dimension in the drawing. In this video, we are going to learn about what is information block, which is at the bottom of the sheet, and what are the information that we can provide at that block. As a design engineer, we have to provide maximum information in that block. In that block, and here we are going to see what are the information that we can provide in that block. And we can provide the informations like drawing number. Each drawing should maintain specific number in that in order to avoid confusion. And we can provide the material of the part, and we can provide a title of the drawing. We can also provide a detailer name, approver name, quality department who have approved that drawing. We have to mention each and everything in that block. And here we have to see how can we enter the information in that block. And we have an option called sheet format, which is on the left side of the screen. We have to right click on that sheet format, and we will find an option called edit sheet format option, and we have to select that option. After that, we can see that information block is now editable. And here we can add the necessary information to that information block, or we can link the information to that information block. Here we have entering the information manually. Here we have provide the document number and material for that part, and we can also provide finishing style, and we have to maintain specific finishing. After that, we can provide detailer name who are created the drawing, and we can mention the date on which the drawing is created. And we have an column called approved manufacturing and QA, and we have to enter all the names who have approved that drawing and who had manufacturing the drawing, and QC department have to take care of that. Quality assistant, we have to mention all the names with proper dates on that. In this video, we are going to learn about how can we convert the drawing file into PDF and image format. Initially, we have to save the drawing. After that, we have an option at the drop down of the save button. If we click on that, we have an option called save as. If we select that option, we can see few other save as formats. You can see in that you can observe that we can convert the drawing as DXF format. It will be in AutoCAD format, and we can convert the drawing into e-drawing. And we have an option like PDF. We have to select that option and we can save that drawing file into PDF format, and now the drawing is converted into PDF format. And also we can convert the drawing into many other formats like image formats. Again, we have to go for the same option, save as. After that, we can find a few other options in the drop down, and we have an option called JPG. It will be the image format. If we select that option and save as means, and if we click save means the drawing file is now converted into image format. It will be very useful for taking a printout of that drawing, and we can also provide the drawing in these formats to the quality department or to the manufacturing department. We can provide this drawing in these formats.